the last way we're going to talk about mechanisms and rate law expressions. We're going to get everything for this one, including K and the orders. And we're going to do it experimentally, because that's the deal. You see, you really can't figure out these guys any other way than by running multiple trials. And that's what we're going to do the rest of this week, if we have school the rest of this week. Because we have labs. In lab, we're going to be doing multiple experiments. And in each one, you can't just do one trial. You have to do it a couple of times to be able to figure out the order and the rate, because that's the only way it can be done, experimentally. Can't look at the equation and say, oh, well, the coefficient's 2 or coefficient's 3, that's what the order is. Can't do that. Okay.
Book today.
Great. You're going to need it. Actually, we won't have as much time in your class to work on video. There's no video.
For Friday?
What?
There was no video for Friday?
Oh, yeah, there was. I thought you meant this one. I haven't put it up yet. All right. So the order of the reaction, the order of the reactants, and K can only be determined experimentally, and that's what I got to show you how to do. You're going to have to run the trials multiple times. Let me show you. It's kind of like backwards from what we did here. Don't copy this down. You may remember when I gave you, well, actually I'm going to give these back to you at the end of the period, these sheets. All right? You may remember those. Most people got 10s on them. They weren't very difficult. All right, so if I said I had a rate law expression, rate equals K, A squared, B to the 0, C to the first power, you guys could work it this way. Listen, given you the rate law expression, and I said you doubled A, and you tripled B, and you quadrupled C, everybody could do that. You were pretty good at it. You just plugged it in and figure, okay, 2 squared, B is 0 order, so has no effect, okay, and you put them all together. Well, now I'm saying the exact opposite. I said, I don't know what this is. So you're going to have to run trials where you double A. And then you measure the rate between those two trials. And if the rate doesn't change, there's no change at all, it's 1x from what it was before, and I doubled A, what does that tell me? What is A? 0 order. What if I doubled A and the rate doubles? Then it's first, that the mistake there is people saying it's second order because I doubled A. No, it's a factor by which it changes. So that's what we're going to be doing today. We're going to basically be running multiple experiments, multiple trials, and measuring the rate and seeing how that rate is changed based on how I changed the reactants. And that's what you're going to do in 2 different labs. And those labs are not going to be one period labs. They're going to be probably multiple, more than just even a double period lab to do the calculations. And that's why this week's a bad week to have all the interruptions. But whenever I see you next, we will have a double and count on doing at least one of those labs. All right? So you carry out several trials, you vary the concentrations, and then you measure the rate of the reaction. Now, it takes me a little while to explain. Because I do multiple trials, you have to copy a lot down. You're not going to have to copy this chart down for any of the homework problems or for the test. But for this one example, you do. Okay? Let's do this example. Copy this guy down, and this big chart you're going to have to copy. All right, so there's my equation. 2A plus B plus C yields D plus E. Okay? And I give you this chart, and you need to copy this all down. Okay? I know. It's fun. Copy that whole chart down. That's going to take a little bit of time. But after you copy it, I'll be able to explain to you exactly what's going on. So copy as fast as you can. So the more time you get this done in, the quicker, the more time you'll have to get some of this homework done. And I'll have a chance to even explain a couple more.
This interruption. Just a reminder, all students eligible for the AMC math competition should report to the library at 9:30. Again, all students eligible for the AMC math competition should report to the library at 9:30. Thank you.
No, Harry.
Before you go, Harrison, I'm going to show you. I'm going to tell you what we're going to do with all this. Before you go, I want to tell you what we're going to do with all these, and And then when you see this or when you copy the notes, it'll make sense to you because all you're going to do is we're going to actually show the work for it and the rest of the period. And it's not going to take me the whole period to do this. Copy quickly so I can show this before you leave.
This looks fun.
Shh.
You record.
Yeah. All right.
Wait, I need one more second.
All right, so let me just, while you're finishing up, let me just explain to you what this chart means. It means I did 4 trials of the same experiment, but I varied the concentrations. So I want you to look between, and I'm going to talk about this right now. I'm going to give you the notes on it after Harrison leaves, but just real quickly, let me give you a summary of what you're going to do. Look what I'm going to look, can you find any place where I have held the concentrations of a reactant the same between 2 trials? Well, let's take a look. Between trials 1 and 3, A is held constant. It was 0.2 here, it's 0.2 there. Between trials 1 and 2, A doubled, right? Between trials 1 and 4, it was held constant. What I need to find is 2 trials where everybody but 1 is held constant. Because if I got more than 1 guy changing, I don't know what caused it. For example, I could not use trials 1 and 2, because look what happens between trials 1 and 2. A doubles, B goes up by 1.5, and C remains the same. So the change here could be due to A, or it could be due to B, or it could be due to both of them, right? Can you tell me which 2 trials I might want to take here? I have 2 choices, actually, more than 1 choice here. Which 2 trials could I take where everybody's held constant except for 1 guy? 1 and 3. Between trials 1 and 3, A is held constant, B changes, but C is held constant. That's nice because I know something based on that. I know all of the change in the rate must be due to the B changing because these guys are held the same, weren't they? Did the rate change between trials 1 and 3?
No.
You know the answer then. What order is B? 0. Exactly, because you changed him and it didn't affect the rate. Now, I'm simply going to show you in the next 10, 15 minutes how you're going to show me the work for that. Because the fact is you can do all this in your head. All of this is done in your head like I just showed you there. Like Harrison just saw. You can go now. But, are you going to?
Yeah.
Oh, okay. I didn't hear you. Okay. But I'm going to show that you're going to have to learn how to show the work for all this. Because otherwise I have no way to give you partial credit. So I'm going to show you how to do the work for it. Okay? All right. Copy this down. These are the steps. First step, find, as I said, 2 trials where everybody but 1 is kept the same.
Copy this down. I will. I will watch the video.
He's behind.
Where the conch.
So, find 2 trials, and we already found 2. 1 and 3 work. It's not the only 2 you could have chosen, but they are definitely ones that work. 1 and 3, I'm going to use where those 2 are held the same. So, the first thing you would do is simply identify it. I know this sounds crazy, but obviously you're not going to write these words down. These are notes. When you go to show a homework problem, the first thing you're going to do is tell me which 2 trials you chose. And in this case, you're going to say trials 1 and 3. Okay? Those are the 2 trials you chose. That's your answer to the first step. Now, once you do that, I have to have a way of mathematically showing this. And you're going to see when I get done with it, you did it in your head. You know darn well, when you go back to this guy here, you know darn well that A didn't change, C didn't change, and this guy did, but the rate didn't. So you know he's 0 order. How are you going to show that so I know that you knew that and you didn't just guess? Here's how. Okay? After you do that, you're going to, we already chose those. After you do that, you're going to use the rate law expression and plug in what you know, the factors by which these guys changed, and solve for the missing order that you will be able to solve for, the missing exponent. Now, that won't make sense till I do it, so let me show you. Let me get that chart back up here, and I'll show you what I mean. You don't, obviously, this is the same chart. I just had it on the same board so we could see it while we're doing the problem. So in this step, what are you doing? You're going to write out the rate law expression, and then you're going to look at what happens to this guy below. All right, to each of these guys, we're going to plug in everything we know. Here's the rate law expression. Rate equals K, A to the X, B to the Y, C to the Z. And I know it's a pain writing the brackets, but remember the brackets mean something. They mean moles per liter. Okay? So that's why we put them in brackets. All right. Now, let me explain something here, guys. Look at this down here. We are given some information, but we also have variables. The information we're given is the concentrations in moles per liter and the rate. So I know this, and I know A, and I know B, and I know C for any trial. What I do not know is X, Y, Z, and K. I have 4 variables. There is no way I could solve a problem that has 4 variables in one step.
So just give up.
Right, so just give up. That's what you should do. But if you remember in your algebra class, if you have an algebra equation that has both an X and a Y in it, you have to do it in 2 steps, right? And that's what we're going to do here. We have 4 variables, so we're going to need 4 steps. And the way you work this, again, theoretically, common sense-wise, we already know what the answer is.
1 and 3.
Between 1 and 3, he's held constant, he changes, he doesn't, must be 0 order. But here's how you're going to show that. The factors by which they change. What happened to the rate between trials 1 and 3? What happened to the rate? Nothing, so it's a 1. Okay? I'm going to ignore K for now because as long as I'm at the same temperature, K does not change. So K will be a 1 as well. We're going to kind of ignore K till the very end. K between trials 1, 2, 3, and 4 are always going to be the same. So the factor by which K changed would also be 1. A. What happened to A? Between trials 1 and 3? Nothing. It's 1 raised to the X power. What happened to B between trials 1 and 3? What factor did he go up by? Not 0.1. 0.3 is how much bigger than 0.2? What would I multiply 0.2 by to get 0.3? 1.5. Okay? Raised to the Y power. And finally, C did not change. Raised to the Z power. Now, mathematically, this is why this works. Let's take a look. Mathematically, we know why it works common sense-wise. I've explained it a couple of times. Here's why it works mathematically. I still have 3 variables here. But what is 1 raised to any power? 1. What is 1 raised to any power? 1. So I can solve this because the only guy who's actually involved in this is the 1.5 raised to the Y power. The other guys are going to be kept the same. I'm going to actually get rid of this and show you. Okay, back to this. So here's what your equation becomes. 1.5 to the Y power equals 1. Just wait. I'll answer your question in a second. Let me just finish. 1.5 to the Y power equals 1. That's what your equation becomes mathematically. Theoretically, common sense-wise, we know that means I changed B and nothing happened to the rate. Mathematically, it means 1.5 raised to what power equals 1? What power must Y be?
0.
Exactly. Now, you still have a question?
Yeah.
What?
Where'd you get 1.5 from?
That's what I was.
If you multiply 0.2 by 1.5, what do you get? Let's go back to this.
You get 0.3.
Well, why'd you multiply it?
I'm simply asking, what's the change between these two guys? How much did this guy increase by?
But you only increased by 0.1.
Well, no, the factor by which he increased, that you would multiply it by. For example, 0.2 going to 0.4. What do you multiply 0.2 by to get 0.4? What do you multiply 0.2 by to get 0.4?
Like 2.
2.
Double it.
2. Right? What do I multiply 0.2 by to get 0.3?
1.5.
1.5. That's what I'm talking about. The factor by which it changes, not the amount by which it changes. I'm not talking about 0.5 molar increase.
Jesse, your book is fine.
Okay, got it? All right.
False.
Now, let's go back here. One more thing here. Watch. That is how you solve for one variable. We've got to do this 3 times for all 3 variables, and then I got to do it one more time for K. Because let's take a look at what happens next. So that's your next step. You ready?
But we know they're 1. So why
You do not know that by any means that the otherwise are 1. Let me explain again. You're completely misunderstand. Let me explain. We kept the change between them as 1. They did not change, and therefore we could ignore their exponents. I do not know the exponents are 1. In fact, they're not going to be 1. Let's take a look for the next step. The next step is to find 2 more trials where the same thing applies. Everything's pretty much kept the same, and I can solve for the missing exponent. All right. In this case, actually, I don't have to find 2 trials where everybody is the same, and there's a reason for that. I now know what B is. Okay. So there's your next. This is our next step. Underneath this, you're going to write down your next notes. Erase these guys first. Let's go back to my thing here. I realize that I probably should have that guy be a little bit larger. This guy's A, so you know. This guy was A. This guy was B. This guy was C. All right. We already know what B is. I don't like those colors. Hold on. A, B, C. We already know what C is. What did we figure out the order of C is? The order of B is? 0. We know he's 0 order. All right. Look at these guys. What 2 trials you want to take now where I want to make sure that I'm changing one of these guys but holding C constant or A constant? What?
2 and 3.
If I take trials 2 and 3, let's see what happens. This guy gets cut in half. Goes from 0.4 to 0.2, correct?
Yep.
B stays the same, and C stays the same. What happens to the rate?
Changes.
Yeah, by what factor? How much smaller is 2.4 than 9.6? What factor does he change by?
3.
No. Not 4. He's not 4 times this. This number here, if you're going from 2 to 3, what happened to him again?
0.5.
This guy's 1/2 or 0.5, right?
Yeah.
What's this guy?
5.
If I divide 9.6 by 2.4, what are you going to get? You're going to get 4, like you said. So that means this guy's 1/4 the size of him, correct? Okay. Well, either way, we're going to plug all that in, and we're going to see what we get for the answer. Does anybody know what the answer is going to be? If I cut this guy in half and he gets cut by 1/4, what's that mean he is? What order does he have to be? You've been doing these for several days. It has to be second order, right? He got cut in half, and this guy got cut by 1/4. He must have been second order. And as you'll see when I go to do this problem right now, watch. Okay. Actually, I'm going to leave that one up there. Let's go back there for a second, so we can still see it. All right. So I write them again. Underneath this, now you're going to write this again. Rate equals K. A to the X. B is no longer to the Y. We now know he is to the 0. And C is to the Z power. Got it? Now, looking at that chart below, what happened to the rate between trials 2 and 3? Wait. You should write over here also. Trials 2 and 3 are what we're using. Write that down. Trials 2 and 3. So, yeah, the rate is cut by 1/4. It's 1/4 of what it was. Again, K stays the same. As long as the temperature is the same, K is the same. What happened to A between trials 2 and 3? It went from 0.4 to 0.2, 1/2. And you can use, by the way, decimals if you wanted to. Lizzie said 0.5. That's true, it's 0.5. And this number here, what would you multiply him by to get that guy? 0.25, all right, which is the same as 1/4. What happened to B? He stayed the same, raised to the 0 power. What happened to C? He stayed the same, raised to the Z power. Got it? Now that I got all that written in there, I'll get rid of the box so we can finish it up. Okay. Let's finish this up. These guys, they're going to be 1. Because 1 raised to any power is 1. 1 raised to the 0 power is definitely 1. That's a 1 already anyway. So 1/4 equals 1/2 to the X power. What must X be? What must X be? X is not 1.
Well, it's 2.
Why'd you say 1?
No, I was talking.
You were talking and saying
No.
1.
Yeah, but not about that. Something different.
So he's 2.
I said that it
You
was
said
2
number
earlier, so I
1.
knew what it was.
All right, so X is to the 2nd power
Wow.
here in this case. Got it?
Yeah.
All right. Now, it says, let's go back to this again. Find 2 more trials and repeat this. I'm still not done. All right, I've got to try to find 2 more trials and find the last variable. Let's take a look at what happens there. Okay. Oh wait, no, not that. I'll go back to the chart here. Okay, so let's take a look at the chart one more time. I now know A is second order. I now know B is zero order. I'm looking for C. So here, I'll tell you one thing. I'm not going to take trials 1 and 2 or trials 1 and 3 or trials 2 and 3. Why not? Because C doesn't change in those. But the fact is, I could take any other trials is because I don't really care anymore that A and B are changing because I now know what A and B should be. However, I would probably take the easiest one. What do you think the easiest one to take would be? Where you are holding like A constant, for example. 1 and 4 would be a good example, right? Because A is held constant. I don't care what B does. Why don't I care? He's zero order. We already know that. And C is tripling, right? So let's do this. Let's do this thing. All right. We, again, take trials 1 and 4, you said, and then we write the rate law expression. Rate equals K. A, we now know, is to the second power. B, we now know is to the 0. C is my Z power. I don't know what he is yet, but I'll find it out in a minute. By the way, let me in the middle of this last one, so you all understand. The reason I'm showing you how to do this, what to do here. Fact is, you don't have to do this. You could have done each of these in your heads. When we go to start our homework in a minute, I'm going to do the first one with you. We'll be done with it. We'll know the orders in less than a minute just by looking at the chart, because it's not going to be as complicated as this chart. It's not going to have 3 variables. It's not going to have 3 reactants. You'll be able to do it in seconds. This is merely so I can see your rationale and your work and give you partial credit. If you don't show this on the homework, if you don't show this in the test, that's where you lose more points. All right, plug our numbers in. What happened to the rate between trials 1 and 4? Went from 2.4 to 7.2. And by the way, I'm finding that this is the hardest part for this class. Just figuring out the factor by which it changes. Let me give you a hint. What could you do to these guys? Just divide them. Just divide him by him, and you know what you'll get? 3. The factor of 3. It changes by a factor of 3. 1 for K. A, what happened to A between trials 1 and 4?
1.
He just went up by a factor of 1 squared, so it's going to be 1 again. I don't care really what happened to trial B, but I'll say it. B between there, he doubled, raised to the 0 power. And C did what? 2.4 or 0.2 to 0.6. 3 raised to the 0 power. I'll get rid of my chart again so we can see it and finish it up.
It's so disappointing.
All right. Everybody here is 1, with the exception of this guy. 3 to the Z power equals 3. What must Z be? 1. Z must be Salazar. ZMR. Different Z. Okay. Now, some of you are probably also wondering, well, is this ever going to get to the point where I'll have really ugly, exponents? No. The biggest mistake, I'm not quite done. I have one more thing to do, solve for K, but the biggest mistake you'll make will be something like this. 2 raised to the x power equals 2, x equals 2. Is that correct?
No.
No. 2 raised to the x power equals 2. What is x? 1. Another mistake will be like, 3 raised to the x power, calling that third order if it equals 3. It doesn't. To be third order, what would it have to do? It wouldn't even be 9. It'd be what? Third order, 3 raised to the third power, 27. Okay? So that's a huge mistake. Calling 3 to the x power equals 3, x equals 3 is a huge mistake. You're saying it has an effect of 27 times when it really has an effect of tripling it. Okay? All right, anyway, last one I've got to solve for is K. So I'll write this last of the notes down here. Choose any trial and plug in the known values and solve for K. Now we ran out of room at the bottom here, so I put this chart at the top now so we can still see it. And again, I kind of cut out the letters, but this is A. Oops. This is A. This is B. This is C. We now know A is second order, B is 0 order, and C is first order. I have to solve for K. So I'm going to choose any trial. It really makes no difference, but since trial 1 has the exact same concentration for everybody, let's just use him. Okay, so the rate equals K.
We write down the rate to use trial 1.
Yeah, you should. That's right. Trial 1, which one you chose. Rate equals K, A to the second, B to the 0, C to the first. So trial 1. And now I plug in everything I know. I know the rate. It's right there. 2.4 times 10 to the negative 6. I got cut off at molar per second.
Awesome.
K is my unknown. The last thing I have not solved for yet. You say, well, why isn't it 1 this time? This is not the change or the factor by which it's changing.
You're solving.
I'm solving for K. In this case, I'm just taking one trial. What happened? A was concentration was 0.2. Everybody's 0.2 actually. 0.2 molar times 0.2 squared. 0.20 molar to the 0 and 0.20 molar to the first power. So that's what your equation becomes. And all you have is one variable, K. So let's do this math in our heads. 0.2 squared to be 0.04. This is what? 0.2 to the 0 power, 1. So 0.04 times 0.2 is what? 0.0080 molar. And that molar is squared here and 1 there, it'd be to the 3rd power. You add the exponent and you multiply. So 0.0080 molar cubed equals 2.4 times 10 to the negative 6 molar per second. Almost done. What do I do to both sides? Divide by 0.0080 molar. So K would equal 2.4 times 10 to the negative 6 molar per second divided by 0.0080 molar cubed.
That's
Right?
what I'm saying. This,
Divided by 0.0080 molar cubed. Now you can actually do that in your head as well, but if you want to do it in a calculator, you can. If I were doing it in my head, think about it. Here's what it would be. I would change in my head 2.4 to 10 to the negative 6 to 24 because that would go into 8. And I would make that other guy also to an exponent. So it would be kind of like 24 times 10 to the negative 7th over 8 times 10 to the negative 3rd. Why does that make it easier? What's 8 and 24 go? 3 times 10 to the what? Negative 7th minus a negative 3? Negative 7th minus a negative 3? Negative 7th minus a negative 3? Negative 4. The weirdest part about this, by the way, you don't have to do that in your head. You can just grab your calculator. All right? You could just grab your calculator and do it. You don't need to do that in your head. However, the hardest part about this is, the weirdest part about this is the units. Molar cubed into molar gives you molar to the negative second. And you still have your seconds underneath there, which would be seconds to the negative first. Those are your units for K. Yes.
this sucks.
Yeah. Now remember, people, I warned you about this a couple days ago. I warned you that units of a constant are often weird. For example, when I have R from PV equals nRT, it was 0.0821 liter atmospheres per mole Kelvin. No one can visualize a liter atmosphere per mole Kelvin. It's a constant that makes everything work out. The same thing is true in this case. K is a constant. The units of constants are always weird. You should get used to that. In physics class, in chemistry class, they're just weird. They make everything else work out. They're how the other guys are related. So don't be surprised by that.